So just trying to give some pros and cons with this. A lot of these, for people that are familiar with this remote condition-based monitoring, a lot of these are not necessarily unique to phase. So, right, the pros of doing route-based type of work, right, you get that visual and tactical context. For someone like myself, being able to walk around a machine to really get a sense of what's going on. Maybe there's loose bolts, maybe they've shimmed one side of the motor too much, right? These kinds of things give you all kinds of additional context that you're obviously not going to have in that remote based experience. Additionally, being able to do adaptive phase testing. There are different techniques you can use. For example, if you have multi-tier structure to check for where the actual looseness is, this involves moving the sensors several different places. Obviously, this is something we really can't do in that remote context. The last piece here is going to be that sensor precision. So just to put it bluntly, if I'm taking my own readings, I can rest assured that I have the most confidence in my own position of those sensors, making sure they're in the best location to take those phase readings. The downsides of this, again, very similar to condition-based monitoring, what we call the snapshot trap. You're really only getting this phase reading for maybe one period of operation, one speed, whatever the case is, depending on how your system is set up, if you can take phase at all. And some of these things are significantly affected by how the machine is operating, what speeds it's at. For example, unbalance will significantly increase as the speed increases. So really just being able to not only take phase readings, but take those under all the conditions that are necessary can be very challenging. Obviously, from just pure logistics, safety, and access to some of the machines, especially the ones that we monitor, we're not in the early 2010s anymore. Most of our customers are really looking to have these sensors in difficult places to put them, right? Because they don't want to be doing repair and maintenance work in cases that they don't need to, and that are very challenging to access to take vibration readings, let alone do maintenance. And obviously, labor intensive, you need someone that's intelligent as far as the phase intelligence, knowing how to take this, have experience, what to kind of do with those readings over time, et cetera. So just specific skills. So then on the condition-based, remote side of this, right, the pros of this, large data set context. So what I mean by this, and I'm going to show a good example of this later, there are many cases in which phase is not going to be a perfect solution. We're going to go through the cases that it is, but there are also cases that it's not going to give you a clear black and white answer. However, with the ability to trend vibration data, for us, it's typically once an hour, if not more. Vibration, temperature, for us, magnetic data has us have the ability to detect speed changes over time, so operational conditions. We can also take in additional data from the customer, think, process parameters, those sorts of things. So having this data as well as another piece of that puzzle, even if in cases it doesn't give us a black and white answer, is something that we can lean on in the future. And this is not something you can kind of do in that traditional route-based sense. That second part I mentioned here, that speed load correlation, this is huge, especially for Augury. We have customers that very much run their machines all over the place, speed-wise, conditions-wise, maybe different products, these kinds of things. We're going to be opening this phase capability to not just sort of the standard machines that, vibration analysts are expecting to see these on, fans, pumps, blowers, things like that, those more simple machines. We're going to be employing this to every sensor, that we have that has this capability. So even those more complex machines, again, we're going to be able to use this as another piece of that information. Last here is that historic analysis context. So being able to, again, cross-reference over time if we had similar kind of phase changes with the vibration in the past. So really being able to pinpoint specific solutions to each customer with our platform, we're able to then also time sync that. So for example, if you had a repair last year, we see some kind of odd phase shift as well as a very large change in the vibration, right? We can correlate that right to that repair, reference that back, specific things that the customer did at that point. So really trying to continue to keep it custom to that specific scenario. On the con side, again, very, very much the same for just remote based in general. We do have sensor mounting constraints. So there are certain types of phase analysis, I would say the less common needed, but these, we can't move the sensors, right? We put them in the best place they can be to catch, the common faults. So these are where these are going to stay. And then like this last piece here, again, right, we rely on the customers in some cases to put these sensors back on the machines after repairs, things like that. So that's obviously something we need to work with the customer to try to keep consistency, at least with the physical location, right? If we're several inches from a bearing and those kinds of things, again, this is just kind of natural to all remote-based condition monitoring, but just kind of wanted to show that here as far as what we see in the pros and cons.